Alright, in this video, let's talk about the transformations compared with the parent function that you would get by making all these little changes. So the parent function here is just 3 to the x power, but here I have all this extra stuff. I'm adding and subtracting numbers on the end with the exponent, I'm multiplying in the front, and I even have a negative sign here. I'm actually going to start with this middle one, because that's the most normal type of a one. So look, if you have a number in the front like this 5 right here, that is either going to be a vertical stretch or a vertical compression. It's either going to be getting taller or shorter, depending on whether or not this number is bigger than 1. So because 5 is bigger than 1, that is a vertical stretch by a factor of 5. On the other hand, when we get over here, this is what a vertical compression would look like, because 1/4, of course, is less than 1. So, you know what? I think I will type these answers, because I don't have a ton of space. All right, so we have a vertical stretch by a factor of 5. Okay, now let's talk about the 3. Actually, the 3 is part of the parent function. That's just the base. So let's not talk about the 3. That's not a transformation. So next, let's talk about this -4. When you're adding and subtracting in the exponent, that's going to be a left or right motion, but it will be the opposite of what you would normally think. So a -4 will actually send you to the right by 4. So let me just write that down. So this will go, hold on, and I think I'd like to color coordinate it if I can. So I'm going to make it blue like that arrow. Okay, so here we go, right 4. Now here comes the -1 on the end. So that -1, when you have something adding or subtracting on the end, technical difficulties, you guys. This is going to be an up or a down motion. And this one works just like you would normally think. So -1 will be down 1. All right, so these are the so there are only these 3 transformations on problem number 4. And I guess I did not really need all of that much space. Okay. With that in mind, I guess I will slide over to C. Okay, now like I said, because this 1/4 is less than 1, instead of being a vertical stretch, it's going to be a vertical compression. Okay, vertical compression by a factor of 1/4. Okay, this time there is no number being added or subtracted to the exponent, so there won't be a left or a right. So I'll just delete that part of it. Now we have a +2. So instead of being down, this time it will be up. So up 2. Because of that, of course. Now, let's go back and take a look at A. Let's see, can I squeeze this in here? Alright, now I have this negative sign here, which is sort of like, hold on. It's sort of like having negative 1 times 3 to the x plus 2 power. Now this will not be a vertical stretch or a vertical compression like the 5 and the 1/4 were, because the number 1 does not give you a stretch or a compression. But because of the negative sign, it will be a reflection over the x-axis. In addition to that, we have one other thing, and that is this plus 2 on the end. You know what, I guess I was doing that in blue. Alright, these left-right motions, similar to the x minus 4 that's right here. The x minus 4, remember, sent us to the right 4, so you can bet that x plus 2 is going to send us to the left 2. And that's it. Those are the only two transformations. Alright, so that's it for problem number 4. Just scanning over one more time. You can see it all. And so I'm going to stop this video here, even though it's very short. On my next video, we will be solving exponential equations such as these.